Thank you very much honoured to be on the stage with Ermias here, really to lead the Q&A session here, so very much an honour to do that. So for those that don't know me, and I do recognise a lot of faces in the crowd here, I'm Steven Morrison, I'm at AFBI and I head up the Sustainable Livestock Systems branch in AFBI. So again, when you're getting your questions ready, I think there is a roaming mic in the middle here, so you can get your questions ready, but obviously I've been taking a lot of notes and I have lots of questions, so again, we'll kick off maybe with one of those ones you've probably heard quite a lot of. Obviously, you went through a lot of strategies and techniques to potentially reduce our methane emissions. But where do you think, or what's your impression around the world about the social acceptance of methane inhibitors, for example?
Right, thank you. So I think it really depends on how things are communicated. Right now, we're working with the University of British Columbia to try to figure out what is the consumer acceptance on this. There was a lot of work actually being presented at this summit last week in Davis, and what they've seen is that when you just simply ask questions about which one is this acceptable to you, and most people say yes, depending on what additive people are using. Like with seaweed, for example, people seem to be quite comfortable. And I think with 3-NOP, I think maybe 50% or so people said that that's okay. But then when they're given information, when they say, before they ask them, they will say, like, there's climate change happening, this is, we have some mitigation that we can do. Once you frame it that way, then it went up. So on all of them, 3-NOP or seaweed or all the feed additives, the acceptance level really went up. So I think it's just how you frame the questions, but yeah, we have to be very much aware of how this is communicated and how it is framed to see what level of acceptance. From farmers' perspective, at least in California, there's very open, particularly in dairy farmers. So dairy farmers in California are very open in using feed additives and basically say, well, you tell us what works. Then we can do it. A little bit more resistance from beef farmers, but it's just that they feel that there's not enough additives work that's been done that's relevant to beef production in pasture systems. But if there is, I think the acceptance would be pretty good.
Again, just following up on that one there. So the sort of the importance of the communication and how that's brought across both to the general public and the farmers that will be taking these on board. But in your sort of experience around the world, where do you think we're going to be at in terms of inhibitors or dietary sort of strategies in 3, 4, 5 years' time? Is it one particular product, or is it going to be lots of combinations?
Yeah. The way I see it, that I think it's going to be different combinations, particularly those that we can put together with stacking of different mitigation strategies. I think that's probably the way to go. I think the next few years we will see more and more experiments done on stacking. I think so far we've been mostly focused on different feed additives and their effectiveness and all that. But I think I'll see more and more experiments that have been done when you put 2 or even 3 different feed additives. How does it work? Like you can use vaccines, for example. Vaccines will give you 15%, 20% reduction, and then you can add whether 3-NOP or seaweed, one of the inhibitors on that way. And then on top of that, you can have rumen modifiers. It could be tannins or lipids, or so those 3 things would work differently. So one is, we have the antigen production. The other one we have inhibitor, we have enzymes, and then we have the other ones that are sort of more competition in the rumen for hydrogen. So if you do it that way, potentially you can get over that 50% mark for reduction. So theoretically, it should work, but we have to do it experimentally to be able to say this is what's happening. And a lot of the protocols that would help you quantify the emissions, that's what they're saying also. You can use it if experimentally shown that these are additive effects, then you can use it. Otherwise, you have to just focus on one. But I think, the stacking issue is an exciting prospect.
Any questions coming from the crowd? Everyone's very quiet this evening. No hands up yet. Again, it is a hot topic on the stacking, but it goes back to that what you mentioned there about that sort of monitoring, reporting, verification process for these strategies. And where do we see that moving in the future? And again, I'll add an extra question in there just to confuse things, but how do we ensure that these products are being used the way they should be used?
Yeah, I think the first question is probably easier to answer than the second one. But in terms of the protocol development, I think that's been happening already, and there are carbon markets or verifiers or people who put together protocols like Vera in the US, for example. They have already have a protocol for feed additives. So there's a way in which you can quantify, and there are some things that you have to do in terms of methodology. Which methodology are you using in terms of measuring of emissions? So there are some that are more credible than others. So you have to use those, and meta-analysis is kind of almost required. If not, you have to have at least 3 experiments that have been done on this specific feed additive in order to be able to say, this is the effectiveness, and then you have to also show that the effectiveness varies with diet and how much it varies. So the protocol development is ongoing. There is a carbon market in the US developing with Athian in particular, and they have their own process. So basically, people who are interested in this, they will submit the protocol to Athian, and then Athian has an advisory board that will send this to the advisory board, and then the advisory board will look into the protocol, and then they have interviews with the people who are proposing this, and then through that process they will approve the protocol. And then once it's approved, it becomes part of their portfolio, and then people can apply to use those protocols and reduce methane emissions. And within a very short period of time, they've already started issuing credits. And so far, they have issued $5 million worth of credits to farmers using this protocols. And then in the next few weeks, they were saying they're in the process of issuing another $10 million in credits. So this really is developing well, and hopefully the same. I see the initiative here in the UK as well that will help in that direction. And the second one is, how do we know that we're getting the emission reductions? Right now we are really depending on models, but whether those models are accurate, whether the models are based on controlled experiments, so whether they are translated into commercial operations, I think that's something that we need to work on. What we are doing in California, working with Caltech, is and with NASA, is to send a satellite and then measure emissions. It's a high resolution satellite. So there is a couple of satellites now already, but the resolution is not enough to pick up differences within a farm. So this satellite we are working on sending is really to figure out within a farm how much emission is happening. So when you do interventions, it doesn't matter whether it is manure or enteric, then you will be able to quantify at that farm level. So the only one you can do now, I guess, is there's a 100,000 beef farm in California that you can see from space. That's the only one you can see if there is any reduction that you're doing or not. But other farms, more the average range in California being about 1,000 dairy cow, for example. So those ones you need to have a more resolution. But again, this is solutions coming up in the next 5 years. This is if NASA, the budget for NASA is not cut, which is a big issue. It may be cut, and we won't have that satellite going up. But there are other solutions that people are working on. Measurements that are now done for commercial, like for oil and gas industry, at that level you can do it. At the farm level, you can do it. For research it's difficult because you need to pick up differences within animals. But if you want to do it for a whole farm, that kind of thing would be good. But it's not scalable. I think the scalable solution that we're working on is if you have a satellite, then you have the data, then it's already scaled up. but farm on farm is going to be quite expensive to do.
Yeah. Oh, I see a question from the back there.
Well, very interesting talk. I'm just quite interested in your Methane AI slide. Have you used it in your lab? How accurate? Could you just give us more details on that?
Unfortunately, I don't have much detail on that. So the company, Methane AI, they are the ones who are doing this work, and the way they're explaining it is that they have a proprietary way of analyzing microbiomes and identifying specific microbes that are associated with methane reduction potential. So basically, the way it works is that they will collect rumen samples from a herd, and they run through this modeling process, and they will identify those specific targets. And if those are present or absent or something like that, they will be able to predict whether a feed additive would work in that herd or not. So that's the premise, but I have not seen a paper detailing on exactly how that works.
Oh, lots of hands in the front line.
Thank you, Ermias. That was an excellent gallop through all the technologies for methane. If I put my farmer hat on, and I asked you to look into the future, and we have targets around 2030 and 2040, 2050, where realistically do you think will be being able to apply technologies in 2030, 2040, 2050? And I have Steven a follow-up if I may.
Yeah, so I think by 2030, I would be comfortable saying 30% reduction is achievable. So with the vaccines have a huge potential. It's not a lot of reduction, but you will get 15%, and then maybe they get better. You can get up to 20% reduction. If you get that consistently, you're already halfway there, and then you can add some of the already proven ones, the bovine, you will get 25-30% there. I think the question is going to be how cost effective is it, or how expensive are these technologies, or what kind of incentives farmers are getting in order to be able to use that. So the development of markets like Athene, for example, is really good, because then you can at least cover some of that cost. And if there are additives that would help in improvement in productivity, that's even better. But at the moment, we don't have those. It's mostly targeting the methanogenesis. So depending on the incentives, I think the uptake would be good, and I think we'll get that. I think 30% by 2030 is achievable, and then as you go to 2040, 2050, I think it will definitely be above 50% reduction. I think you can see that happening. Yeah.
Did this take the microphone actually?
Yeah.
Sorry, I'm allowed a second one. That must be good, yeah, I guess, Ermias, I'm thinking about all of this is down to what happens to hydrogen in the rumen,
Yeah.
and hydrogen shuttling, and so on. What's happening to that hydrogen where you're getting the major reductions in methane production? Where is it going? And secondly, within that, are we seeing any benefit? I know you showed productivity, questionable, but that whole thinking in ruminant nutrition would be there's also energy conservation, if you like, and channeling that energy elsewhere. So thanks.
Yeah, I think that's a very good question. I think the issue really is on now becoming more and more on the hydrogen, and that's why we are shifting our attention to hydrogen utilization rather than reducing methane within this project I talked about. At the moment, a lot of the hydrogen is being exhaled out, so the energy that contains within hydrogen is not captured. So there are one or two experiments that have been shown where when you use additives, and then you can use, I don't remember the compound, fluoro something. It's a mouthful. Basically, that could help take on the hydrogen, and so that you can use that hydrogen for productive purposes. Now, what we've seen is that you don't see productivity increases until you see the emissions are going above 50%. So below 50% emissions, you're not going to get much, but above 50%, there seems to be a productivity benefit. But still, we really need to redirect that hydrogen to be used for productive purposes, because hydrogen is indirectly a greenhouse gas as well. So we don't really want, I think that has a GWP of 11 or something like that. So we don't want that hydrogen for reasons of energy conservation as well as for greenhouse gas as well. So yeah, I think as people become more comfortable that we're using feed additives, we have to turn our attention what's happening to that hydrogen. How do we make use of that hydrogen? How do we promote hydrogen utilizing microbes within the rumen as well?
Thanks, Professor. Thanks for sharing. I have a quick question. As you mentioned, you have battery analysis, and so with the treatment with the bromoform, is it have any statistical differences of the methane emission between the charcoal and the beef, and why? Thank you.
Yeah, so this was a question we struggled a little bit in the meta-analysis, because if you do just a pure meta-analysis, you would see there is no effect, but you can see there is effect, if you know what I mean. Statistically, with the methods that have been applied before, you cannot take that, it will come out as not significant. But if you looked into the data a little bit more deeper, there are some fundamental differences between dairy and beef cattle, and that's why we provided different equations for dairy and for beef. They're not drastically different. I mean, we provided one for everything, like for dairy and beef together, and then one for dairy and the other one for beef. And you're not going to get drastically different results if you use one or the other. It's going to be very close. But it's just the substrate base is different on beef and dairy, and then sort of the rumen volume differences there as well. In dairy is obviously much bigger in terms of intake. We have 20-25 kilos intake, and beef we have about 10 kilos intake. So the levels are different, and so we've seen some impact of that, where the effectiveness seems to be better in beef cattle than in dairy in some instances. Particularly in a feedlot cattle, there's going to be higher reductions in a combination of the diet as well as of the smaller rumen as well. So that's why we try to differentiate it. But any of those three equations will give you, close to what you would expect.
I think we're down to our last question. So our last question is just over here with Tara.
Okay.
Thank you, sir. Curtis from Apple. What do you think about the future in the big context of the climate change?
Definitely, the byproducts, they have advantages not just in terms of reduction of emissions, but also in terms of reducing the ingredients as well. So we're actually doing a life cycle assessment right now. When you're doing byproducts, you're reducing the other, could be maize silage or rice silage or something like that you are replacing. So when you make those silages, there's associated emissions as well. So you're saving that emissions as well by using those products. And then if you really want to get fancy and do a consequential LCA, you would also say, well, those byproducts would have gone into a landfill and they would have produced methane and all that. So you're saving all that as well. So I think definitely using byproducts would help in the circular economy. It would be an easier way to integrate it, because particularly if there's going to be a financial benefit using that. And then on top of that, then you can use that. So this stacking idea of using byproducts as a base to start with, and then depending on incentives and availability and cost, then you can move on into feed additives that specifically target methanogens as well.
Thank you very much. I think we've finished in terms of time for the questions. I know there'll be maybe at the end there'll be an opportunity afterwards if you want to have a quick question, but we're up against time. So I'm going to hand over. Thank you very much.
Thank you.
A lot of questions in a very short period of time, and I'm lucky enough I'm going to be asking lots of questions tomorrow when you visit us.
Yeah.
So thank you very much.
Okay, thank you.
Thanks, Stephen. Gerry Boyle is my name. I'm Chairman of AgriSearch. On behalf of AgriSearch and Queen's, just to let you know that this was jointly organised by both organisations, of course as part of the Dairy Carbon Network. And I was absolutely delighted to be here this evening to listen to Professor Kebreab's talk. I'm probably one of the few people in this room that has been to your home country Eritrea on several occasions, and I'm actually in the process of editing the first scientific dairy conference that was ever held in Asmara last year, and I'm hoping to put final touches to that publication in the near future. But this was really a splendid lecture, absolutely splendid. And what really impressed me was the very close interaction between the university and industry. And I think that's really, really important, given the challenge we have to persuade our farmers to use the technologies that you have talked about. It's very clear from what you said that we have solutions. We have reason to be very positive about the carbon challenge on our farms. But persuading farmers to use these technologies is an equally big challenge. And I come to this discussion from the perspective of an economist. All of these technologies we would classify, or the reason for using these technologies, economists classify as addressing the negative externality problem. Unfortunately, and I was delighted you emphasised the potential gains in some cases for live weight gain and milk production, but the direct impact is of course the reduction of methane. And there is no benefit for the farmer in reducing methane. And when I talk to farmers, that's the first thing to say to me. And so the onus then is on us to design policy interventions and to persuade government that there are solutions. And I'm not sure that I share your full optimism in relation to this part of the world, that by 2030 we will deliver our targets. I don't tend to be a pessimist by nature, but without significant intervention by the state, that won't happen. These technologies have to be subsidised. In most cases, this part of the world anyway, what we've got are targets and lots of spreadsheet analysis. We've solved the problem on the spreadsheet on many, many occasions, but I think there is a challenge there for the design of policy. And my only other comment is, which I thought was very interesting. Clearly your focus was on enteric fermentation, and you did refer to the challenge of stored manures. And many of you in the audience, I'm sure, are familiar with the study that was recently published in the UK, which suggested that we may have been substantially underestimating the production of methane from stored slurries. And I was really shocked by this report, because it went on to say that, according to these scientists, that there's nearly as much methane generated from stored manure as from enteric fermentation in the case of dairy farms in the UK. So that's a challenge. And the only other final comment, and again your talk sparked so much reflection on my part. I'm a great believer, of course, in the advocacy of productivity-led mitigation strategies. But, and particularly in developing countries. Developing countries are entitled to grow their assets in terms of cow numbers and so on. But what tends to happen here is, farmers being farmers, productivity generates profits, profits encourage them to have more cows, so we end up with a falling footprint. I'm talking about the south now in particular, but yet total emissions are rising per farm, because farmers are smart. And they say, great, we have productivity boost, we'll put that into growing our cow numbers. So anyway, look, thanks again, it's been a really stimulating presentation, and thanks to Stephen for chairing the discussion. It's given us lots of food for thought, so thank you again.